Good morning and welcome to the SpiceWorld Spiceworks 2021 virtual conference. This is the opening talk of what will be a series of very interesting talks today by some very impressive humans. What we're going to be talking about is why second-hand is no longer second best, the second user market in general, the opportunities that provides for IT managers and support, and that'll be looking at cost performance of supply chain, world politics, everything that's good about philosophy, everything we can cram into 30 minutes. So some introductions. This is Ashford Wynne. She's the sustainability lead at Techbuyer and also the chair of the Data Center Alliance's special interest group on sustainability. So she knows a lot about a lot. And I'm Rich Kenny. I'm the IT director at Techbuyer and I know a lot about IT. So Ashford's going to kick us off and talk about the right to repair in the USA, and we'll start with the sort of political landscape, if that's cool.
Yeah, so I believe there will be other people at this conference who are higher profile than even my good self, who will be talking about the right to repair. I'm sure some of you will have seen the headlines. There's a successful floor vote in the Senate, June this year. Biden popped up.
He did.
And supported it, which was nice, in July. And the legislation, Severson has paused, but hoping to pick it up again in 2022.
So what does it mean for everybody then? What's so good about the right to repair?
This is what I like. Yeah. It's kind of the language that's used around that.
Right, don't we?
The messaging and how it ties into people's emotions. So the people behind the right to repair began with agriculture.
Yep.
For good reason.
Yep.
Because it's something that ties to the American psyche, ties to independence, self-reliance, the land, all the good stuff.
All the good stuff.
I don't think it's an accident that it's called the right to repair, because that ties to another part of the American psyche.
Yeah.
You know, Bill of Rights.
Yeah. Right to free speech, all that sort of stuff, right?
Yeah. And when you look at the rationale behind it, it's a lot about emotive issues. So it's a lot about who owns this equipment, who has the right to sell it on, who has the right to pull it apart, start again, who has the right to design their own systems and make what they have bought work for them and not get shut down by a software application.
And the opposite of the right to make things obsolete, right? When you haven't finished using them.
Yeah.
And that's what we're trying to block, I suppose, right?
Yeah.
It's trying to stop that forced obsolescence.
Yeah.
That says, you may not be done with it, but I'm done supporting you with it.
Yes. Or I'm done making it work, so I'm going to turn off the piece of software that makes that component part work, so that you can't sell it to your friend or another company who might be able to find a use for it when you no longer have a use for it. Yeah.
Or even just keep using it yourself at the way it was when you first bought it, right?
Yeah, it's been turned off by somebody a long way away when you thought you'd bought it. You thought you'd paid money and you had something that was yours. It turns out you didn't. Mm-hmm. You just had a gateway into something that was nebulous and out of your control. So there's a lot about ownership and independence there. Yeah. There's a lot of talk about vendor lock-in and how you escape from that. And then there's also the environmental message.
Yeah, and that's kind of one of the key crucial ones now, right? Is looking at the environmental cost of this disposable society. Yeah,
and that's something that's picked up, across the pond in the UK and the EU. The legislation that's happening there, that's much more closely allied, I guess, to environmental considerations.
And preventing waste unnecessarily.
Yeah, so there's a lot of conversation in the UK at the moment about the rising tide of e-waste, which globally is about 53 million tonnes a year.
The fastest growing waste stream in the world, probably.
It is, and predicted to be 120 million tonnes by 2030.
It's a lot of stuff that's useful being thrown away unnecessarily, right?
Yeah, not just being thrown away, but poisoning the land, poisoning the water table, stuff that we won't get back. Yeah. Like destruction of ICT can be responsible for carcinogens. Yeah.
Stuff we don't want.
Also in the developing world, with kids pouring sulfuric acid on pieces of equipment, maybe we don't want that either.
Yeah. I can see why we wouldn't want that.
We wouldn't want that. So it's a lot about electronic waste, and it also ties into developing more circular attitudes. So the EU, their right to repair came out after their circular economy action plan, which was all about how we can make materials last longer in a society that's using about 2.5 times roughly per annum what the Earth is able to replenish or recover from.
And that's where you have early in the year, like Earth Overshoot Day, don't you? Where you've used your entire allotment for the goods for this year.
Yeah,
and you shouldn't be using any more.
May.
Yeah, well, 2.5 times past that, right?
Yeah.
On an annual basis. So that's a problem.
Yeah, that is a problem. And that's something that the legislators are looking at, and they're also tying it to energy. Right. So the Eco-Design Directive, which was one of the first pieces of legislation out in the EU, originally was about energy usage and energy optimisation, which then tied to embodied carbon in the equipment and material scarcity and everything else. So by the time we get to summer of this year, which is when the UK finally gets around to introducing right to repair rules, we're talking again about emotive issues, we're talking about domestic goods, because that's what people can get their heads around, we're talking about collection of electronic waste and how to encourage that, and then the press starts talking about what the benefits are.
So this is job creation, economic value.
So there's significant
big ideas.
Social value in second-hand equipment, not just in avoiding damage to the environment and the associated social knock-on effects,
but the positive actual economic macro effects, I suppose.
Yeah, so a second-hand iPhone is worth about 50% of its new equivalent on the secondary market. If you recycled that iPhone,
it's a fraction,
it would be 0.23% of the economic value. So there's that economic value retention, and there's job creation. So we're talking 45,000 jobs in the next 15 years.
Supporting repair and
refurbishment as a result of right to repair.
So that's a serious economic impact then.
Yeah. So those are the societal benefits, and then the benefits to customers. We've kind of talked about that in the emotive issues. But basically you're giving people back freedom to design whole systems, to decide what they want to do, first and foremost. What, like our guys are always saying, what do you want this system to do for you? Let's start from there, and then let's build out from
rather
there.
than we've got this system, what can it do? It's what do you need?
We've
this
got
is the
this
appropriate choice.
shiny new shaking thing that's got all these bells and whistles. Right, let's figure out how to use it later. Or let's start from need and then build appropriately. And as part of that, you get to pick and choose amongst suppliers. Because if you go to the secondary market, you just buy the components and you can put them together within reason, the way that you want. I mean, not within servers necessarily, but when you can pick, we'll have such and such manufacturer in this area of the business, and we'll have such and such manufacturer in another. And avoid
that vendor lock-in, which limits your possibilities, I suppose.
Like for the public sector, we see a lot of people in government in the UK buying servers from a particular manufacturer because they're best on networking. Because they've signed a contract. They haven't actually looked at what they need. Right?
Yeah, that's right. So they can't actually make the best decisions on cost or performance. They have to make it based on some arbitrary measure around what's agreed. So it's about freedom to choose, freedom to design, getting better performance bang for your energy and materials buck, but also for how much money you laid out. If I can get this for like 10 quid and it gives me this performance, why would I pay 40 for it? Absolutely, that makes sense. So that seems really straightforward. That seems really obvious. So there's a cost, there's a performance piece. So what are the drivers behind why people do buy and why they don't buy then? So you did some research on this, didn't you? We did some research. We got a guy from a local university to do some surveys for us. He surveyed large customers who did buy secondary equipment, and then he went to other customers who were not buying secondary equipment, and he asked them why that was. And it was interesting because the people who bought from us, predictably, were doing it on cost and performance. So they spent less, the performance was equivalent or increased, and if they bought through us, who were a fairly large secondary supplier, there was a lot of choice, so there was a lot and
of
the availability is there, it's short returns, all that sort of stuff.
So when he then interviewed people who weren't buying secondary equipment, they came back with similar answers. They were saying it's too cheap, it's too good to be true. There's a performance risk. There's a perception of failure.
Yeah.
which may or may not be true. I haven't got any evidence that it's not true, and I'm also worried because if it does fail, because there's that perception of failure,
It's my fault.
it's my fault, my job's on the line, they're going to point at you use secondary equipment rather than primary equipment, and that's what went wrong. Whereas if I buy it from the manufacturer and it returns, then it's like, well, it's not my fault.
Yeah, so even if the warranty is identical, if everything's exactly the same, you're still kind of on the hook for making a better decision.
Yeah.
I get it.
And then there's also this issue about availability. There's an assumption that if you go to the new market, that it's going to be immediately available. That's highly debatable, as we'll come to later.
Yeah.
But
The bit one's a tricky one, isn't it?
we started looking at that together and saying, what evidence is there out there that we can use to crush these perceptions?
Yeah, okay. So the cost one's straightforward, isn't it? Because you can see the actual list price, you can see the other prices out there. So cost you look at and go, that speaks for itself, right? So performance, I guess, is the big one. Because what you're saying is, and what the research is saying is that people are worried that performance isn't the same.
Yes.
Okay, so
and cost helps with that, right?
Because, yeah, absolutely, yeah. So I guess the best thing to do then is to do like a 2-year project where you spend thousands of hours proving it.
Yeah, we could do. We could get
that.
a university involved, so that it wasn't just us saying it.
That would work.
What happened?
So let's do that.
Let's do that.
And let's start that back in 2019, and then we can present it in 2021 at this conference.
And here we are.
Okay, that works. Okay. So that's what we've done. And when I say us, I mean us as a business associated with research institutions and people that are completely non-invested financially in this but are interested in the pursuit of science on this, which we'll come to in a moment. So I guess one of the key things to talk about when we talk about performance is understanding how performance degrades over time. So there's a big difference between a mechanical part and an electronic part. So the reason that right to repair is interesting around agricultural is because most of the aspects of an agricultural remanufacture will require replacement of parts. Mm-hmm. They wear. So in a car, for example, or a tractor, you have pistons, those pistons move, there's an element of friction. That friction leads to degradation, wear and tear. You need to replace that part. Not everything, but aspects of it. That doesn't happen with electrical equipment. The more you use a CPU, you don't have a set number of hours that your CPU can be used before it runs out. You do with some mechanical hard drives, but you don't really have that with memory. You don't have that with systems boards. You don't have that with a lot of the equipment that makes up ICT. So the worry that they'll wear out isn't actually
valid.
Yeah, I guess. Yeah, I mean it's something you'd consider, but it's not. It doesn't degrade the performance.
Yeah.
So I guess the best way to do that is to run a set of thousands of experiments that prove that.
Yeah, so it's not just you saying it.
Yeah, exactly.
It's machines that are measuring it. And
15 years of experience telling you this isn't a thing across hundreds of people in multiple businesses saying it isn't a thing. But let's take that knowledge and experience out of it and let's scientifically prove it, right?
Mm-hmm.
So that's what we did. So we carried out like-for-like scenarios, and in this case it's on servers. So in this case we took a Generation 9 server, which is circa 2014, and we had it everything brand new versus everything refurbished. Side-by-side test them. And when I say brand new, I mean like videotaping them coming out of the box, undoing the packaging, completely making sure that this is factory sealed from the manufacturer.
And that evidence logged with the university.
Absolutely, because it has to be repeatable methodology. It has to be. You can't just be like, oh, this was new, trust me. It needs to be, it needs to be clear. And then you carry out the tests, and you do every single component new, every single component refurbished. What's the performance look like? What's the inefficiency look like? Then you do component level swap outs one at a time. You swap out the CPUs that were new and put in refurbished ones. Run the tests again across multiple temperatures, multiple tests, and then hundreds of hours later you kind of got a series of information around that. You then put the new CPUs back in, and then you replace with refurbished memory, and so on. So you've worked through line by line every single component in a server, and what that'll give you is a series of test results. And those test scenarios will tell you that there is no discernible difference between the refurbished and the original in packaging equipment. Nothing. Thousands of hours of tests will tell you they're identical. And the way those tests are run, you use something that everyone in the industry uses. So you use SpecPower, or use a cert by SpecPower. So cert is what creates the performance and energy metrics for servers. And it's what all your manufacturers, your HPs, your Dell, Cisco, it's what they put inside the box for Energy Star rating. So you use the same tool that they do to prove their performance, to prove their performance on refurbished and on new, like by like, and then you've got a test set that's comparable. Mm-hmm. Now, the way cert works is it carries out a series of tests called worklets, and they stress different parts of the architecture, so the CPU, the storage, the memory, and they have appropriate tests based on that. And what you have is then a weighted mean, and this is important because 65% of the performance and energy efficiency is down to CPU. So 2/3 of what we're looking at from a performance point of view comes from one component. So you should really look at that component quite closely.
Yeah, because it's a beast.
Because it's the most important piece, yeah. And the CPU, there's a law associated with the CPU called Moore's law, which means that every 2 years it will either halve in size or double in density, so double in performance theoretically for the same size chip. And that law is called Moore's law. That's been around, I mean, technically it's been something around since the 1800s apparently, but specifically in regards to CPU architecture, it's the sort of 70s. And work that we did alongside with the Uptime Institute disproved Moore's law from 2015 onwards in CPU architecture. So what we had is we had this doubling of performance and we had this increasing in energy efficiency. And that was true, that's been true for 35 years. And then around about 2015, what you saw is the incremental change in performance dropped off. So it went from it being double to it being 10, 13, 17% improved performance. But what we actually saw at the same time, due to the density of the cores on them now, the actual active idle power was becoming less efficient. So where the server spends the majority of its time, and I'm using the word server, it could easily be laptop, where it spends most of its time is at active idle. So it's on, but it's not doing a right lot. And that's become less energy efficient in the new architectures of the CPUs, whereas the actual top-end performance is become incrementally, not double, but 13%. So I guess the analogy that's really good for this is having two cars. So you've got a car that does 190 miles an hour currently, so it can drive 190 miles an hour, that's its top speed, and you spend most of its time at 30 to 90 or 30 to 70, I guess, depending on how you drive. 70, it's 70. And it's spending most of its time 30 to 70, and it's very efficient at running at 30 to 70 miles an hour, top speed 190. The new ones have come out, they've got top speed of 200 miles an hour. So if you need to drive at 200 miles an hour, your previous generation can't.
Yeah.
So you need to buy that race car.
But in a real life scenario.
99% of the time and 99% of the population are only going to use it for that 30 to 70 miles an hour. And at that, it's worse than the previous generation. So on a car analogy, you basically bought the wrong car to drive to the shops. That's what we're disproving here.
Yeah, and this chart looks at the analysis of CPU trends over time.
Yeah.
So what we did was we tested that in a real life situation.
That's right. That's right. And we tested that across hundreds and thousands of scenarios where that can then spin out. So to do that, we look at configuration. So understanding now that refurbished and new are identical, and understanding this trend in CPUs, which is the key driver of energy efficiency and performance, we need to look at configuration cross-generationally now. So in this case, we're looking at brand new generation, I should say, versus brand new or refurbished or previous past. Yeah. So it's like for like. So we've got base configurations, and what you've got is a base configuration of the previous generation being 13% less performant, less energy efficient than new. So new is now 13% better. But that's 13%. That isn't 100%. That isn't twice as good. That's 13%.
And it's going to cost you a lot more.
Like a lot more. If you can get the parts.
Yeah.
Like if you can get them, because that's a problem too.
And if you don't mind spending a ton of carbon making it.
Exactly right. Yeah. So we're looking just entirely on cost. On the carbon cost, it's high.
Yeah.
So what then we look at is, would changing the configuration of the previous generation allow it to perform the same as a new generation? And in this case, the slide I'm showing you at the moment, that's the change of just a CPU. So a base CPU to a slightly better one, not a top-end one, but a slightly better one. It's now completely removed the deficit it had with the new generation, and it's made it 2% better. So now a previous generation one, just changing the CPU and keeping everything else the same and identical to the new generation, is now better. Performance, energy efficiency. Okay, that's good.
Yeah.
So we take the CPU out, we just change just the RAM, because the difference is really small, it's 13%, so it's no longer massive improvements needed. And what we find is that now the previous generation is 17% better. So it's overcome its 13% deficit and become 17% better just from doubling the RAM.
And this is what I find really interesting, because when I spoke to people inside the sector a few years ago, they would say, you always have to replace. The sustainable option is always to replace servers with the latest version because of the efficiencies when you plug it in.
Yeah, and that's...
it will use a lot less energy, therefore a lot less carbon, so therefore it's your most sustainable option.
Yeah.
What they were relying on for that information was CPU changes.
That's right.
And what we're seeing here is that doubling the RAM is cheating those CPU changes.
Yeah. Between these generations, because it's worth saying that like the generation prior to the ones we're testing, so we're looking at 9 and 10 now, you could never get a Gen 8 to outperform the Gen 9 because the CPU architecture was a 2012 CPU versus what would be 2014 onwards. and the 2014 ones wouldn't fit in a previous generation socket. So what you're saying is that we've hit this sweet spot in time where this is now true, whereas it potentially has never been true before.
Yeah,
and in the future it might cease to be true.
Yeah, but
right
what
now,
we're also saying is that you need to, again, look at what you've got.
Yeah.
Right?
Yeah.
And design the best system with what you've got in front of you.
For how you want to use it right now. And that's exactly right. And that's, so we're looking on that the final configuration we're looking at is exactly that. So making a RAM and a CPU improvement has a increased incremental effect, which makes it 36% better. So we're talking tiny improvements on components. So we're not talking about top-end components here. This is significant cost savings, and you need more than a decent base spec to improve that. So that's what we've got to. How that plays out when you put that through specialist software and you put it across a data center estate, and which is in the slide now, this is a 4-year cost projection of running a data center with 366 older servers and what you could do to optimize energy, carbon, cost on a refresh. And in this case, it would say go from 366 servers to 56 previous generation. Now, it'd probably still be 56 new ones, but we're talking we can go previous generation, and that would save 3 million kilowatts of energy, 1,000 tons of carbon, hundreds of thousands of pounds worth of cost. And all that it's saving is all waste right now. It's waste payments on energy, it's waste payments on equipment and on maintenance. And that's what we're trying to do. We're trying to figure out how does that play into your estate. And this is the same thing with laptops, right? You've got a estate of laptops, use them 3 years, they're probably good for 7 years. Double the RAM, and it'll save you a whole procurement cycle or a whole lease cycle on laptops for a tiny cost and a massive environmental saving, which is cool. So the most important thing is this wasn't done just by us. This has been verified by the IEEE. So the IEEE is probably the world's leading authority when it comes to technology. These are independently assessed people who have nothing to do with the industry, but just scientists, and they check the methodologies, they check the results, they check the hypothesis. A lot of questions, a lot of paperwork, and in the end, the work we're talking about here just got published in the Transactional Sustainable Computing in December 2020, and they've actually put a link on here, so you can actually go download that paper. It's all fully open sourced, which I think's beneficial if you're interested. Yeah. And that includes all the assumptions and everything else. So what we're saying here has been scientifically proven. This isn't opinion. This isn't a white paper. This is now an area of fact. It isn't because Astrid and Rich said so. No, because you wouldn't want to trust me. No, definitely not me. Trust some people that are smarter than me. And what we're saying here is the most of the testing's done on servers because that's what we're specialists in. But this is the same thing for laptops. This is the same thing for desktops. This is the same thing for NUCs, for workstations, for anything that's in your IT estate. The principles are the same. Component level upgrades can significantly improve the life of your products and allow you greater deals of customization, flexibility, cost savings, environmental savings, and that's what we're trying to get to, right? So we've covered cost, we've covered performance. Let's look a little bit at availability and why second-hand is not second best on availability. So let's talk supply chain. So a thing happened recently, if you've heard about it, it's called COVID. Yeah, snuck in there. Snuck in there a little bit. In there. And it flagged up some issues in the short term which are likely to become long-term issues. Yeah. One thing that we found out was that the supply chain is not very resilient. Yeah, it's a fragile one, isn't it? It is a fragile one. We were, in the sector that we work in, we were seeing chip shortages at the end of 2019 before COVID hit the US and the EU. Those have gone on and on and on and affected more and more sectors. Yeah, we've got major car manufacturers shut down now because they can't, build even cars. Still. Yeah, even still. I think it was Toyota, they had chips in reserve, they now run out of reserves. Yeah. We can't get this new equipment. And that's a problem for car manufacturer, it's a problem for kids trying to access online education if they get sent home because they've been quarantined, it's a problem for entire remote workforces, you can't get equipment to actually access remote workforces, it's a problem for people who are self-isolating and can't get hold of their bank. Yeah. Or they can't order shopping because they don't have the equipment. We saw a massive upsurge in demand in secondary equipment during all lockdowns. In the first lockdown, we saw an 85% increase in new customers coming to us. We also gave what we could to people who needed the equipment just because, but that's a different issue. Yeah.
And a lot of them came back to us because those issues around perception, they'd been forced to take the leap.
Yeah,
right?
And once they've made it, you don't really want to step back, because why would you pay more for less?
Now, following on from that, people are realising, consumers are realising that the supply chains are vulnerable. Governments have got that in sharp focus now.
And part of that's because of the complexity of the supply chain, right?
It's partly because of the complexity of supply chain. It's also because things are more fragile than we think. I mean, look what happened with the PPE.
Yeah.
You know, this is not like, I mean, it's not simple equipment, but it's not as complex as ICT.
Yeah.
We couldn't get the supply in. So it's affecting all sorts of things. For ICT, we're looking, yes, as you said, complex supply chain. A lot of the materials themselves are mined in the developing world. They're shipped generally to the Far East to create the components and subsystems. So predominantly China, but also places like Thailand and Singapore and other Southeast Asian countries. Then they're shipped for assembly in the US and Europe. And then there are other bits and pieces like packaging that come in, and then they're shipped to secondary users, and then it's all shipped in reverse pretty much at end of life. So when we're looking at all of that and we take it down to materials level, we find out that the US government is worried about the availability of these materials.
Yeah, and we're talking critical materials here.
We are talking critical materials.
Yeah.
That are necessary for all sorts of industries. And the US has created a list of 35 of them.
Okay.
And they're, like the driver of this list is basically saying, if it's not available within our borders, then it's a risk because we need it and we can't control that supply chain. And we're looking at this list and we're seeing quite a number of materials that are for ICT. They're also for other industries that are supposed to drag us out of the mess that we're in.
So this is for like renewable energy and all that sort of stuff, right?
Solar panels, wind turbines. The prices on copper have doubled over the past year because they're under increased demand by the policies that have been put in place to try and reduce carbon output.
And you're struggling to actually reclaim these as well, right? So we're talking about they're difficult to get hold of in the first instances. They exist outside the borders. They're used in everything that's going to solve our problems, you know, to fix the shortages we've got. And you also can't recover them, especially in ICT, right?
No, you can't because of the fact they're in trace amounts. They're in amalgams, and some of them are just basically non-recyclable with current technologies.
So there are technologies out there, aren't there, that are kind of working towards this, things like bioleaching and things.
There's bioleaching, there's pyrolysis it's called, which is sort of like heat without fire, which melts down some of these materials and recovers them. But we're talking about things that are happening at really small scale.
So this is like research level stuff as opposed to commercial viable products, right?
Yeah, and when you talk to the people involved, they say, well, that's fine, we can do it, but in order to develop this, we need critical mass. And at the moment, they're focusing on gold and high value items at the moment. They're not looking at cobalt economically. They're not looking at the other stuff that you like, which is on this list. They're not looking at antimony. They're not looking at...
I'm going to throw out tantalum because it's my favourite.
Tantalum's Rich's favourite.
Can't make a mobile phone without tantalum. It's a fact. It's a fact. But there is, like you said, you're looking at the materials, lithium, tungsten, aluminium, you know, all of these things are used in so many materials, but they all exist in ICT and they're unrecoverable. So just building more things using these isn't going to work.
So we've got to look about where this is coming from, you know, where we've got the raw materials to build this stuff.
So we've got the same.
We're saying it's outside the US, which is a problem for the US government, and
we're also saying it's outside the EU as well, right?
We're saying it's outside the EU, so the EU have their own list of 30 critical raw materials, which have been identified as in politically unstable supply, but also in low supply. So this table is from the British Geological Survey risk list from quite a while ago.
So it's worse now.
Yeah, it'll be worse now because we've had increased production of wind turbines, solar. We've had like an increased focus on that, so I guess the figures will have changed slightly. But what they're basically saying is that this stuff is not in the ground either.
Yeah.
You know, like there's fragility in the supply chain, but there's also
limited amounts.
Yeah, not enough.
Yeah.
Unless we go to the seabed and start drilling in there. Which I'm all for, actually.
Yeah,
Who needs marine life?
That and asteroids, that's the way to go.
Yeah,
seems viable. So you've put together a little like a global risk rating where these two things kind
of... Just for fun.
Yeah, because we like to see a balance.
This has not been peer reviewed by the IEEE. Just pointing out that is
it's
something
probably not even a spell check, to be honest.
No, it hasn't. I just made it on my laptop. And then showed you because it's pretty and it's got a lot of red in it.
I like it.
It's got loads of red.
And you put tantalum on there for me, which was appreciated.
We're looking at the critical raw materials, or rare materials in servers here. We've made a little list of them, and we're seeing that there is high risk. Yeah.
Across the entire Western world at this point in time.
Yeah, and we've just looked at servers because that's what we know. Yeah. So if we pulled that out to PCs, laptops, phones, we probably have other materials in there.
Much larger.
Yeah, in greater amounts.
Okay.
So when we're talking about second-hand not being second best, there's a traditional argument that you would use to a customer, cost performance, now availability.
Yeah, it's a critical one.
Yeah.
We're also talking energy efficiency, waste reduction, environmental impact, ability to create a positive macroeconomic effect. We were talking about the clean jobs earlier on and what that supports around the right to repair. So we're looking at a lot of reasons now. We are looking at a lot of reasons why second-hand is not just not second best, it's actually our optimum solution. Yeah, our preferred choice. Hopefully. Yeah, because it means that we can control what we have, we can make best use of what we have, and we can rely on what we have. Yeah. So what we've got in our ICT stays within reach, and we have viable ways of developing it and making it last longer. Yeah. And all the positive effects that come from extending that use life. Yeah, and then, in an ideal world, we reuse as much as possible. That gives our recyclers, that we mentioned before, time to develop these at commercial scale. It gives us time to develop a fully functioning circular economy where we are recovering materials, where we've got the designers looking at alternatives that can be recovered, because we're not just talking about component parts being recovered, we're also talking about the materials that have been created. Yeah. So can we give our designers time to figure out what will work on those materials and be broken down? Yeah. And what the crossover is between those two. Very good. So we're going to answer some questions now, if you've got any. Fire them straight over and we'll answer the best of our knowledge, I guess. Mm-hmm. Thanks for your time today. Thank you very much. Thank you very much.